All right, chapter 9, day 1, the start of trig. What we're going to focus on for today is how do we find values for trig functions? And so the trig functions that you've used in the past, sine, cosine, and tangent. And what are coterminal angles? We're going to look at those two things today. So I think back in your middle school years, 9th grade years, you had to work with trig functions a little bit. Well, I know some people called this SOHCAHTOA, some people called it some old hen caught another hen taking oats away. I don't know, whatever method you use to remember it, I call it SOHCAHTOA. It's a way to remember the relationships between sine, cosine, and tangent. And so if we recall what SOHCAHTOA was, sine of the angle is the relationship of the opposite side to the hypotenuse. Cosine of the angle is the adjacent over hypotenuse. Tangent of the angle is the opposite over adjacent. Okay, so keeping that in mind, let's see if we can find some trig functions. So we have a right triangle, given right triangle ABC with sides 7, 24, and 25. Find the sine of A, the cosine of A, and the tangent of A. So we're only going to be focusing on angle A. So if I look just here at angle A, I need to identify the opposite, the adjacent, and the hypotenuse. Well, the hypotenuse is always across from the 90. So I know that this is the hypotenuse. Now, according to this angle, the side across from the angle we're trying to find is called the opposite, and the side next to the angle we're trying to find is called the adjacent. If I'm adjacent to something, I'm next to them. So now, if I want to find sine, cosine, and tangent, I need those values. Well, the largest value in a right triangle will be the hypotenuse. So let's call this side 25. We'll call this side 24, and we'll call this side 7. All right? In a problem, they will give you a little bit more information about the angles to decide what goes where, but if this is triangle ABC and it's laid out 7, 24, 25, then this will be side little a, side little b, side little c, little a, which is across from the big A, little b, which is across from the big B, little c, which is across from the big C. Okay, that's not the hard part about the problem. That's just laying out the triangle. So now let's find the sine of angle A. Well, sine, SOHCAHTOA, opposite over hypotenuse. It's opposite over hypotenuse. So the sine of A is, well, according to angle A, the number opposite is 7 over their hypotenuse, which is 25. And that is the sine of angle A, 7 over 25. Let's try the cosine of angle A. Cosine, adjacent over hypotenuse. All right? So the cosine of angle A is the adjacent. What's adjacent to angle A? The 24, and the hypotenuse is 25. So the cosine of angle A is the fraction 24 over 25. Let's try the tangent of angle A. Opposite over adjacent. So the tangent of angle A is, well, opposite from A is 7, adjacent 24. And so find the sine, cos, and tangent of angle A. There they are, 7 over 25, 24 over 25, and 7 over 24. Now, if I was talking about angle B, then I would have to relabel these. This is still always going to be the hypotenuse, but if I'm talking about angle B, then this would have been the adjacent. This would have been the opposite. Okay, so you have to be careful on which angle you're talking about. And here specifically, we only wanted angle A, so there's the trig functions for angle A. Let's look at angles as we look at them in a circle. All right, we have some vocabulary that we want to talk about. And the first vocabulary word is called standard position. An angle is in standard position when the vertex, which is the pointy part of the angle, all right, is at the origin, which is the center of the XY axis. And the initial or starting side is the positive x-axis. All right, so let's take a look. Angle in standard position. So here's an angle in standard position. All right, the vertex is at the origin. Okay, so here's my vertex at the origin. All right. The initial starting side is the x-axis, positive x-axis. So the angle starts here. This angle went all the way to here in this case. Okay? Where it ends is called the terminal side. Terminating, ending, terminal side is right here. So this angle goes from here to here. Now, when it sweeps out counterclockwise, it is a positive angle. If it went the other way, it would be negative. All right? So this is a 235-degree angle. The initial side, or starting side, ending side, terminal. Okay? Here's an example of another angle. Starts here and goes downward, the opposite direction. That's a negative angle. In this case, I made a negative 35-degree angle. These are just some examples of angles. And when we talk about what quadrant they lie in, again, quadrant 1, 2, 3, and 4 is how we number these. So this would be in quadrant 4. If my angle is more than 360, I just keep going after I come all the way around. So I start here. Again, this would have been 90, 180, 270, 360. Here's a 420-degree angle. So I keep going. How much? Well, 360 plus 60 more. This is 60 more, this little bit. But this whole thing is 420 degrees, positive. And this would end up in quadrant 1. So we have to get used to drawing angles in standard position, which means start at the x-axis, keep going until you end on the terminal side. So here's a 235-degree angle, just for example. Here's a negative 35-degree angle, for example. Here's something more than 360, but you keep going. This one's 420 degrees. Okay? Coterminal angles. Again, our focus was all about trig functions and coterminal angles. All right, so coterminal. Again, terminal, terminate, where they end. Co, meaning they have the same ending. Angles that have the same terminal side. Okay? So, for example, I can start here and I can make a 310-degree angle. All right, for example. Here we go. I could have, if I wanted to, just went the other way. Negative 50 degrees. These would end at the same spot. Okay? Because 310 plus another 50 is going to be 360 degrees. This angle terminates right here. This is the terminal side. 310 and negative 50 are considered coterminal because they would end up in the same location. All right? So you could pick any angle. Let's try one more. Let's go all the way, let's say right here. So let's say this is a 230-degree angle to here. And I wanted to know what was coterminal to it. Well, to find a coterminal, I have to ask myself, how far this way would I go? Well, I would go 90 plus a little bit more. How much more? Well, if I added this and this together, I would get 360. So 360 minus the 230 that I have gives me 130 degrees. So this is 130, but negative because I went the other direction. And so one of your tasks that you're going to have to do is find an angle coterminal to another angle. They have to add up to 360 when they do that. Okay? If I think back to this angle, this is 420, I could have went positive 360, and that would have been coterminal to positive 420. So one doesn't have to be negative and the other positive. We just have to make sure they end up in the same spot. So if you're more than 360, you could always come up with something less than 360 to be coterminal to it. All right? And so we're going to practice that stuff today in class.